So in this video, we're going to write an equation for a quadratic function when given 3 points that are on the parabola. And in order to do this, we're going to focus on standard form. So remember that our standard form of our quadratic function is y equals a times x squared plus b times x plus c. So in order to write this particular equation, we will need values for a, b, and c. So as I stated on the previous slide, we're going to use standard form to help us out here. So remember, your standard form is y equals ax squared plus bx plus c. And you'll need to have values for a, b, and c in order to write this equation. So what we're going to do with these points is we're actually going to hypothetically take each point and substitute it into this equation. Now remember, this point has values for x and for y. So that's what we're going to do. And I'm going to start with point 1 here, and I'm going to create 3 different equations, one for each point. So in point 1, my y value is 4. So I have 4 equals, and I then have a times my x value of negative 1 squared plus b times my x value of negative 1 plus c. Now, a couple of things I know. I know that negative 1 squared equals 1. So I know that this is really 1a plus, well, I have negative 1 times b, so I have negative 1b plus c, and that all equals 4. So notice that I created an equation that has a missing value of a, b, and c, but I was able to create an equation for that first point. So now what I'm going to do is I'm going to move on and I'm going to create an equation for this second point. So here I have an x value of 0 and a y value of 1. So again, I'm going to substitute my values in. So my x value is 0 and my y value is 1. So following this format up here, I have 1 equals a times 0 squared plus b times 0 plus c. Now if I simplify this a little bit, I know that 0 squared is 0 and anything times 0 is 0. So I know that this term cancels out. And b times 0 also cancels out. So what I find here in this example is I find that 1 is equal to c. And that's my second equation. That's what that second point tells me. Now my third point here is the point 2, 7. So I'm going to focus on that point third. And so my y value is 7, so I have 7 equals a times x squared, so that's 2 squared, plus I have b times x, which is 2, plus c. So this becomes 7 equals, well, I know that 2 squared is 4, so that becomes 4a plus b times 2 is 2b plus c. So notice that I was able to take each point and create a unique equation about it. So now I'm just going to rewrite all of these equations up here together. So this first one, I'm going to write the variables first. So I have 1a plus a negative 1b plus c equals 4. I then have c equals 1, and I have 4a plus 2b plus c equals 7. Now I'm not sure if you're noticing this or not, but what we have here are 3 equations and 3 variables. So this is very similar to the 3 variable systems that we solved earlier in the class. So what we need to do is we need to use the information provided as well as some combination of elimination and substitution in order to find what a, b, and c are equal to. Now what I noticed is that in this second equation here, it actually gave me one of the variable values. So I need to find my a, b, and c values so I can write my equation in standard form. Well, I already know that c is equal to 1 because they gave that to me as I created that second equation with point 0, 1. So what I'm going to do here is I'm going to substitute 1 into those other 2 equations for c. So if I do that, I end up with 1a plus negative 1b plus 1 equals 4. And then I want to get all of the non-variable terms together, so I'm going to subtract 1 on each side. So I end up with 1a plus negative 1b is equal to 3. And then the second equation here, I have 4a plus 2b plus 1 equals 7. And again, I want to get those non-variable terms together. So I subtract 1 from each side, and I end up with 4a plus 2b is equal to 6. So if you notice here, I've used that, and I've taken this down to a 2-equation, 2-variable system. So here I can choose to use substitution or elimination to solve for my values for a and b. And I'm choosing to use elimination because I notice that if I multiply this first equation through by a positive 2, I'll be able to eliminate my b values. So if I multiply through, I end up with 2a plus a negative 2b is equal to 6. Then I have 4a plus 2b is equal to 6. And if I add that straight down, I end up with 6a is equal to 12. So if I divide both sides by 6, I find that my a value is equal to 2. And then I can take my values for a and c, and I can calculate my b value. Now it doesn't matter which of the equations on the screen you pick, so I'm just going to pick this equation right here because it looks really easy to work with. So here I have 1a plus a negative 1b equals 3. So I take my a value of 2 and substitute it in there. So I have 1 times 2 plus negative 1b equals 3. So that's 2 plus negative 1b equals 3. Subtract 2 from each side. Negative 1b is equal to 1, so I divide by negative 1. And I find that my b value is equal to a negative 1. So now all I need to do is write my equation into standard form by using the a, b, and c values that I found using my 3-variable system solving. So I have y is equal to my a value of 2 times x squared plus my b value of negative 1 times x plus my c value of 1. So now we're going to take what we've learned and apply it to a new word problem situation. So this problem says NASA can create a weightless environment by flying a plane in parabolic paths. The table below shows height h in feet of a plane t seconds after starting the flight path. Write a quadratic function to model the data. Then use the function to determine what the height of the plane will be when weightless flight begins at 20.8 seconds after takeoff. So here we have to write an equation, and then we have to use it to determine when that weightless flight, at what height that will occur. So here, remember that time is typically an x variable, so that means that height is our y. So what we really have here are a bunch of x, y coordinates. And what we're going to do is we're going to use our standard form equation again, which you should remember is y equals ax squared plus bx plus c. And we're going to write 3 points, any 3 points that we choose, into standard form, and then we're going to use them to find my a, b, and c values. So it doesn't matter which 3 points you pick. I'm just going to pick the first 3 points here. So I'm going to make that point 1, that point 2, and that point 3. But you can pick any points you want. Regardless of the points you pick, you will find the correct quadratic function. So let's start with point 1 here. And remember, we're going to take the xy pairs and we're going to substitute them into standard form. So here I have a y value of 26,900 is equal to a times, we have 10 squared, plus b times 10 plus c. So that becomes 26,900 is equal to, well, 10 squared is 100, so 100a plus 10b plus c. So there is my first equation. Then from here, I'm going to do point 2. So we have 29025 is equal to a times 15 squared plus B times 15 plus C. So that becomes 29025 is equal to 15 squared is 225A plus 15B plus C. So there's my second equation. And then I'm going to take my third point and write another equation. So I have my third point here. So that's 30,600 is equal to A times 20 squared plus B times 20 plus C. So this becomes 30,600 is equal to 400A plus 20B plus C. So there I have my three equations using 3 points from my situation. So I'm going to write my three equations up above, and I'm going to write the variables first just because I like how that looks a little bit better. So I have 100A plus 10B plus C equals 26,900. I then have 225A plus 15B plus C equals 29,025. And then I have 400A plus 20B plus C is equal to 30,600. So then from here, I need to decide how I want to tackle solving this three variable system. So I'm going to use elimination because to me that's just a little bit easier to use. I'm going to give myself more space here as well. So I'm going to use elimination, and when I look at those variables, what I notice is that every equation contains just a single C. So what I'm going to do here is I'm going to focus on eliminating my C's out of each equation first. So that's what I'm going to focus on first. And what I'm going to do is I'm just going to multiply through this first equation by -1, and in doing so, I should be able to combine it with the other two equations and eliminate it. So I'm going to start by combining equations 1 and 2. So that first equation multiplied through by -1 becomes -100. A. -10B minus 1C equals a -26,900. And if I combined it with that second equation, I get 225A plus 15B plus 1C equals 29,025. So if I add straight down, I have 125A plus 5B. The C's cancel out, and then those two numbers on the end combined to be 2,125. So here I have a new equation that eliminates C. And then I'm going to eliminate C again by combining equations 1 and 3. So again, I have the same -100A minus 10B minus 1C equals -26,900. But then I'm combining it with 400A plus 20B plus 1C equals 30,600. So if I add straight down here, I end up with 300A plus 10B is equal to 3,700. So I've used elimination to eliminate C, and I now have two equations that contain two variables. So I'm going to bring these together up here and link them together. So I have 125A plus 5B is equal to 2,125. And then I have 300A plus 10B is equal to 3,700. So now I need to eliminate another variable. And because I noticed that 5 and 10 are pretty easy to make the same, I'm going to choose to eliminate B by multiplying this first equation through by -2. So if I do so, I end up with -250A plus -10B is equal to a -4,250. So then if I add straight down here, I end up with 50A, the B's cancel out, and I have a -550 and 50. So my last step here to find my A value is just to divide by 50. So I find my A value is equal to negative 11. So I've now found one value in my standard form equation. So now I'm going to use that A value and I'm going to work backwards. So I'm going to take this A value, substitute it back in here and find my B value. So I have 125 times negative 11 plus 5b is equal to 2125. Well, 125 times a negative 11 is negative 1375. Then I have plus 5b equals 2125. So I'm going to add 1375 to each side. So we have 5b is equal to 3,500. So our last step is to divide by 5, and we find that our b value is equal to 700. So now I need to also find my c value. So I'm going to erase some space here so I have a little more space to work with. And I'm going to take my values for a and for b, and I'm going to plug them back into one of those original equations. So I tend to go with the equation that has the smaller coefficient. So this first one is the one I'm probably going to focus on, but it would work in any of them. So now I have 100a, which is negative 11, plus 10b, which is 700, plus c is equal to 26,900. So 100 times negative 11 is just negative 1100. Then plus, we have 10 times 7, which is 7,000. Plus c is equal to 26,900. So if we combine these two together, we get 5,900 plus c is equal to 26,900. So if I subtract 5,900 from each side, I end up with c is equal to 21,000. So after all of this work, I finally found a, b, and c to write my equation here for part 1. So I can write my equation here as y equals my a value of negative 11 times x squared plus my b value of 700 times x plus my c value of 21,000. So the last thing I need to do here is I need to answer that final question of what is the height going to be at the 20.8 second mark when weightless flight can actually begin. So all we need to do here to answer this final question is we need to take our equation that we just wrote down there in orange, and we are going to plug in 20.8 seconds to find the height at that time. So here I have y is equal to negative 11 times 20.8 squared plus 700 times 20.8 plus 21,000. And if I plug that all into my calculator, I find that weightless flight is going to begin at 30,896 feet.